Okay, this is lesson 12-3 and 4. We're going to combine two of them because they go together. 12-3 is area of composite figures. 12-4 is 3D shapes. So you could put 12-3/4, area of composite figures, and 3D shapes. Okay, so the first thing you're going to need to do is write this down. You don't have to write this center part about the words, but put the shape with the formula for the area of that shape. Now, a parallelogram means any shape with opposite sides that are parallel. Specifically, a parallelogram is where they are slanted, but a rectangle is also a parallelogram, and technically a square is a parallelogram. Anything that has opposite sides that are parallel is a parallelogram. Just like we know, this is the same formula for area of a rectangle. So put a parallelogram, and its area equals base times height. It has to be a lowercase b. Capital B means something else. Then we have a triangle, and its formula area is 1/2 base times height. If you notice, the area of a triangle is just half of the area of a rectangle, because if you take a parallelogram and cut it diagonally, you have two triangles. A triangle is half of a parallelogram. Okay, so write that for triangle. Trapezoid is any shape that just has one pair of opposite sides that are parallelograms, or that are parallel, This is normally what we see for a trapezoid, but it doesn't have to look like that. And this is the formula for it. Area equals 1/2 the height times base 1 plus base 2. Because you have different size bases. And then the last one, a circle. Area of a circle is pi r squared, r to the second power. R to the second power. So write those down. Pause it if you need to still do that. Okay, so the first thing we're talking about is composite figures. A composite figure is made up of two or more shapes put together. And you can find the area of them, and it says to decompose the figure, or basically break it apart into shapes that we know formulas for. So, like looking at this shape, we can cut it right there where that dotted line is, and then we have a parallelogram and a rectangle. I could find those two areas separately and then add them together to find the total area of that shape. Okay, just like this shape, if you cut it here, that's half a circle or a semicircle and a square. And this shape, if you cut it right there, you have a triangle over here and a trapezoid over here because it has one pair of parallel lines. So let's try one. So it says find the area of the composite figure. So this is our whole shape right here, and they give us some measurements. So we are going to separate that. They went ahead and showed us the dotted line of where to separate it into a rectangle and a triangle. Now I can find the areas. I know for a rectangle, it's just length times width. So if I look, they give me that this side is 23, this side is 15. So I just have to multiply those together to get 345. But we're not done. And that's also inches squared because we did inches times inches. Okay, now for my triangle, the formula for a triangle, and you'll be able to look back at the ones you have written down. Area equals 1/2 base times height. So the base of a triangle is the longest side. So we have to figure out what this is. Well, I know from here to here is 15 inches. And then they tell me this part is 6 and this part is also 6. 6 plus 6 is 12 plus 15 is 27. So this whole distance is 27. So that's my base. So I have 1/2 times 27 times the height of the triangle. They gave me that as 8. Now from this part, I like to go ahead and multiply these two first in this problem because that's easier. 1/2 of 8 is 4. Then I just have to do 4 times 27, which is 108. So we're still not done. We have to then go back, that's the area of just the triangle, and add those two together to get the total area of that figure. And it is 453 square inches, and we would just write that inches squared. Okay, so I'm going to have y'all try one. Okay, so it says find the area of this composite figure. Round to the nearest tenth if necessary. Okay, so on this one, they've already shown you where to separate it, and using that information and the formulas you know for different areas, try to find the area of that composite figure. Pause the video, try that, and then I will go over it with you. Okay, problem 1 says find the area of this composite figure. So the first thing that we do is we look and turn it into shapes or figures that we know the formula for their area. So if I look, right here would be a triangle just kind of turned on its side. I know the area of a triangle, I'm just going to draw a little triangle, is 1/2 base times height. Then this would be a semicircle or half of a circle. I know the area of a circle is pi r squared, so a semicircle would be half that. So 1/2 pi r squared. I use those two formulas to solve the total area. So looking at my triangle, it's 1/2 base times height, but it's on its side. So this would be our base. This would be the height of the triangle. So for the triangle, I have 1/2 times the base, which is 6 millimeters, times the height, which is 16 millimeters. So you can multiply any order of these. Half of 6 would be 3. So I have 3 meters times 16 meters. Let's see, I haven't worked this out ahead of time. 3 is 18, 3, 4. So the area of the triangle is 48 meters, but we're not done. We're finding the total area. So now we do our circle. The radius, we know, is halfway across the circle. I know all the way across is 6, so halfway our radius would be 3. So I have 1/2 times pi times 3 squared. You have to do that first, order of operations. 3 squared, that means 3 times 3, which is 9. I like to go ahead and multiply these numbers first. It's easier. Half of 9 is 4.5 pi. I'm trying to remember. I just went blank on if we should leave it as pi or not. And I forgot a calculator. And the bell might ring in just a second. Let's see if I can get this. Oh, Lord. Okay. 4.5 pi. We get 14.13. I may leave it pi for now. So let's see. Your total area is going to be adding them together. Meters squared. So pi. Forgot pi. Meters squared. So let's go ahead. 4.5 times pi is 14.1. 48 plus 14.1. 12, 5, 6 is going to be 62.1 meters squared. That's going to be our total area of that composite figure. Okay, often the first step in a multi-step problem is to find the area of a composite figure. So this one is a real-world example. It says a ceiling tile covers 3 square feet. How many tiles are needed to cover this octagonal ceiling shown to the right? Okay, so first let's find the area of this octagonal shaped ceiling. So if you notice, we could draw or cut it in 2 places, and then that would be a trapezoid, another trapezoid that looks the same size, and then a rectangle in the middle. So for our trapezoid, so they only give us information for one of them, so that means they are the same size. Trapezoid is 1/2 times the height times, and in parentheses you have base 1 plus base 2, because the bases are different sizes on a trapezoid. So if we look at that, base 1 or base 2, doesn't matter which one's which, one of them is 10 foot, the other one is 18 foot, and they give us this little height right here is 5 feet. That's the pieces of information I need for the trapezoid. The height is 5, base 1 is 10, base 2 is 18. So we add those together to get 28. Then you have 1/2 times 5 times 28. When you plug that in your calculator, you get 70. That is just for one of those trapezoids. So I know, so far we have this area. To get the other one, they're the same thing. You could just do 70 plus 70 or 70 times 2 to get 140. I still have to get this piece. It's a rectangle, so that's just length times width. 18 times 20, that's 360. So we add those together, and we get 500 square feet. Now, we haven't even answered the question. We just found the total area of everything. It said a ceiling tile covers 3 square feet. How many tiles are needed? So, scroll down some. What we would have to do is see how many 3 square feet are in 500 square feet. So you divide to figure that out. So we say 500 divided by 3, well, it comes out to a decimal. So 166.7, because that just means you're going to need a portion of a tile. Okay, but think about it. When you are buying tiles, you can't just buy half of a tile. You have to buy a whole thing. So you would have to round up on that. To make it 167 tiles, you just wouldn't use all of that last tile. So we would need 167 ceiling tiles to cover that ceiling. So we're going to try, y'all are going to try a real world problem. Says the L-shaped counter shown is to be replaced with a new countertop that costs $52 per square foot. What will be the cost of the new countertop? So first you're going to have to figure out the area of this composite figure and then figure out how much it would cost to replace those countertops. Pause the video, try that problem, and then I will go over it with you. Okay, number 2 tells us the L-shaped counter shown is to be replaced with a new countertop that costs $52 per square foot. What will be the cost of the new countertop? Okay, well, we know it's $52 per square foot, so that means the area. So before I can find the price, we need to find the area of this countertop. So, what did that say, 52? Yeah, I'm going to write that out to the side, since it's $52 per square foot. Okay, well, it's not just a straight counter, it's turned. So, if you notice, we have these little squares. That tells me that those are 90 degrees. Okay, so that's good because that lets us know it's perfect squares or rectangles. So, I'm going to take this, and you could either draw a line here and split it this way, or you could split it this way, and that's the one I'm going to do. Either one would work. Since I split it that way, we know to find the area of a rectangle or a square, it's length times width. So just looking at this little section, one side of it's 3 feet, one side of it's 2 feet. So I know I have 3 times 2, which is 6 feet. That's the area of this section. Now I still have to figure out for the big one. I know all the way across the bottom is 10 feet, all the way up the side is 3. So for that one, I would have 10 times 3, which is 30 feet. The total area would be 30 plus 6, which is 36 feet. But we're not done with this problem. You have to actually go back and answer the question. It said, what would the price be for the new countertops? We know they're $52 per square foot, so that means for 1 square foot, I forgot to square it, we have 36 of them. So we're going to have to take those two numbers and multiply them to see how much it's going to cost to put new countertops down. This is a really good relevant problem. 2 years ago, we put new countertops in, and that's what you have to do. You have to measure it all, and then they give you price per square foot, and then you calculate how much it's going to cost. So that is going to cost $1,872. I took 52 times 36 to get that. Now we're going to look at some 3D shapes. Okay, so looking at this one, we know that that is a cube. Okay, but all 3D shapes, well, not all of them, but they can have other pieces. So if you notice, they went ahead and named each corner of this with a letter. So 3D shapes can have faces, which are the flat polygons on each side. So like this right here would be a face, and you would name it by its edges. So that could be A, D, H, E. Okay, well, this one on top is another one. H, G, C, D. This one over here, A, B, C, D. This to the left side, E, F, G, H. And then on that very back side, G, C, B, F. Now, the one on bottom, that would be called your base. Okay, it's the face. The face that is on bottom is the base. So the base of this figure would be A, B, F, E. Okay, so then edges are where you have two flat surfaces that come together to form a solid line. Okay, so for edges, we have GH, GC, CD, DH. Okay, then we also have this left side, HE, EF, FG. This front side, I already said HD, DA, EA, because I've already said that one. Over here, I have CB, BA. Then on that back side, I've already said all of them except BF. Okay, then we have vertex or vertices for plural. That is where you have 3 or more faces that come together to make a point. So H is a point, a vertex, G, C, D, B, A, F, E. Okay, then we have what's called skew lines. Okay, so it says, notice in the figure above, line GC. So let me switch colors. So they said line GC and DA. And this is just one example. They said, notice how these two lines, they do not intersect. They're not parallel. They're not even in the same plane, which means they will never touch. Those are called skew lines. Skewed means something that's kind of off, so think of it like that. They're totally off the separate plane from each other. One's way over here going this way, one's in a different area going the other direction. Okay, so what we're going to try, we'll do one together. Let's go ahead and first identify some stuff. Okay, so these shapes right here. This one is a triangular prism. Prisms always have rectangles on them. Okay, and then they're named by their base. So the bottom of this one is a triangle. So it's a triangular prism because then it has rectangles on its sides. Okay, so then if you look at the number of bases, it has 2 because you could take it and flip it upside down and it will look exactly the same. Okay, and then it has, and they said the shape of the base is a triangle. It would have 3 faces. The 3 rectangles are your faces. Then you could look at edges. Then you could look at your vertices. So then this one, again, it has rectangles on the sides, but it also has rectangles on top and bottom. So it's a rectangular prism. It's still, prisms always have 2 bases, one on top, one on bottom, the exact opposite each other. And the shape of the base on that one is a rectangle. Here we have a triangular pyramid. Pyramids are named by the shape of their base also. The bottom of this one is a triangle and it all comes up to one vertex. So that is a triangular pyramid. Its sides are also triangles. All pyramids have faces or sides that are triangles. Okay, this one, still a pyramid because it has those triangles on the sides, but the bottom of it says it's a rectangle to me that looks more like a square pyramid, but we'll go with what they say. A rectangular pyramid because its base is a rectangle. Okay, so then they go into more detail about the difference between a prism and a pyramid. A prism will have 2 parallel congruent faces called bases that are exactly opposite each other. A pyramid has 1 base that's a shape and 3 or more triangular faces that all meet at a vertex. Prisms and pyramids are named by the shape of their base. Okay, and then we come down here. These two, these are the unique ones because they have rounded sides. A cylinder has 2 parallel congruent bases connected by a curved surface. A cone has 1 base, circular base, all connected at 1 vertex. So let's look at an example. Erase my stuff from the previous page. Okay. So it says identify this figure, name its bases, faces, edges, and vertices, then identify a pair of skew lines. So we have a lot to do. So first, let's look. We can tell since it all comes up to 1 vertex and the sides are triangles that it is a pyramid. So then we look at the bottom. It has 5 edges. So that is a pentagon. So this is a pentagonal pyramid. Okay. Now it said name the bases. Well, there's just 1 base, and we would name it by its letters, and you just start somewhere on them. We could start with C, B, it doesn't matter. So B, C, D, E, F. As long as you keep them in order, you can go this way or this way. The faces, okay, well, this one out front that we have, that's A, B, C. We have this one over here, A, C, D. This one over here, A, F, B. Then we have that backside, A, E, F, A, E, D. They went ahead and said the base as well because bases technically are faces. Okay, edges, that's where you have straight lines. So like AD, AC, AB, AF, AE. Then we have FE, ED, DC, CB, and BF. Okay, vertices, where you have a corner. So we have C, D, E, F, B, and A. Skew lines means anywhere that you have two lines that are not even in the same direction and they will never intersect. So they used AB, this one out front, with CD, because if you notice, those are never going to touch. They're not even in the same area. You could have said other ones. Okay, there's more than one right answer on there. It just said name one pair. So what we're going to do, I know this is a little confusing, but you're going to try 1A and 1B. You're going to do this. Identify the figure. You should be able to do that. Then name the bases, faces, edges, and vertices. Then identify a pair of skew lines, if you can. Okay. 1A, you should be able to do all of that. 1B may not have all of those things. So try that. You can pause the video, and then I will go over it with you. All right, on 1A and 1B, says to identify the figure first, name the bases, faces, edges, and vertices. Then identify a pair of skew lines. So first, let's identify the figure. Figures are named by the shape of their base. So the bottom of this one is a triangle, and it all comes to one point. That lets me know it's a pyramid. So that is a triangular pyramid. Then it said name the bases, faces, edges, vertices. Okay, so bases is what they sit on. So the base of this one, and the order doesn't matter as long as you go around. So I'm going to say BCD, or you could say CDB or DBC. So BCD, that's the base. Faces would be the sides. So I have side ABC over here. I have this side, ACD. Then we have that back side, ABD. Okay, bases, faces, edges would be anywhere that two flat surfaces come together to form a line. So I have BC, CD, BD, or DB. Then I have AB, AC, and AD. Okay, then that was edges. Now vertices. Vertices are anywhere that it comes to a point. So I have vertice A, B, C, and D. Okay, then it said name two skew lines. Remember, skew lines are two lines that are in separate planes, which means they will never intersect. They're nowhere in the right direction, never will they cross. So if I look up here, there's multiple correct answers on this. It just said name one pair of them. So if I said AB, I would have to find another line that would never cross that. If I look at AB, CD would never cross that. So I could say AB with CD. If I chose AC, this is the most obvious one looking at it. If I choose AC, this line out front, the one that's never going to cross that is that dotted one along the back, BD. That's the one I'm going to write just because it's the easiest. But there are multiple. BD. So you could have also said AD with BC. Those will never cross. All right, on B. So to name this shape, it has a circular base, one vertex on top. So that is a cone, easiest one to identify. Okay, when we were talking about the bases, I can't really name that base. You maybe could say C, but it doesn't really have one. Okay, faces, or its base, you would just say, I guess, a circle. It doesn't really have a base there. There are no faces. It is all flat and circular. There's no edges to form a face. So then, for edges, like I just said, we don't have any edges. It's all curved. Doesn't have any. Vertices, it has one. For the vertices, it has B. And two skew lines, we don't have any. So this one literally just has, that one's kind of, not really, a cone, and it has a vertice of B. That's all you can have on a cone. It's very limited. Okay, we're just going to talk about this one. It says we can have what's called a cross section. Draw and describe the shape resulting from the following vertical, angled, and horizontal cross sections of a cone. So think of it like if you were to slice it what would the inside of that look like? So a vertical slice, if you look at that, that would just be a triangle. This one looks kind of like it would be, it says parabola, but kind of like a semicircle, half of a circle. And this one, if you cut it right there, you would be left with a circle. Okay, I just wanted to kind of show y'all that. Okay, the last example today that we're going to look at together, example 3. A fluoride crystal is shown at the right. Draw the top view and side view. Then draw and describe the shape resulting from a vertical cross-section of this figure. Okay, so think of it when it says top view as if you were looking straight above it, down over it. That would look like this. It would be a rectangle, but then it still has those lines. Okay, the side view would look like this. Now, a vertical cross-section would be kind of like what we looked at above. If I sliced it with like a rectangle piece of paper straight down the middle, this is what it would look like. Okay, so we're going to look at an example of that, and you're going to try it. It says, Lamar and his brother went camping for the weekend. They set up the tent at the right. Draw the top view and side view, then draw and describe the shape resulting from a vertical cross-section of the figure. Okay, so you're going to draw the top view and side view, then draw and describe what shape results from a vertical cross-section. So pause the video, try that, and then I will go over it with you. Okay, on question 3, it says, Lamar and his brother went camping for the weekend. They set up the tent, shown here. Draw the top view and side view, then draw and describe the shape resulting from a vertical cross-section of this figure. Okay, so when I was looking at this problem, I feel like there's part of it that they maybe didn't describe very well and you maybe got confused on the cross-section part. I will show you both options because I feel like both would have been acceptable. Okay, so the first thing we can do is the top view. Okay, so that means if I were to take that tent and look at it straight from above it, looking down onto it, over it, okay? It would look like this. Okay, there's that top crease of the tent, and then it just goes out on both sides. That would be your top view. Okay, the next thing would be the side view. This one and the cross-section to me were confusing because they don't exactly tell you which way is the front of the tent. You know, you don't know if the side of it is the front because that's kind of what they show most of, or if this entrance is the front. But they are saying this is the front of the tent. Okay, so the side view of the tent is just a rectangle. Looking at it from the side, that is all you would see. Okay, so then the last thing, a vertical cross section. Then they said describe what it is. So a vertical cross section means you have to look at the figure dead on from the front. Okay, so if I was just looking at it straight from the front entrance, and then I took basically like a piece of metal or something and just sliced through it, what would I see from the front? So you first have to think about just looking at it straight on from the front, what it would look like. If you cut a slice out of that, it would look just like that. That's it. And you would describe that as a triangle. So the first time I looked at this problem, I thought, well, people might be confused on which way is the front and which way is the side. If you took it to mean this was the front, then all it would switch your side and your vertical cross section. Okay? But that's going to be the last problem we look at today.